Don't touch anything.
I don't touch that. I've learned that.
You just touched it.
Well, not while it's recording.
Oh, I just started recording.
All right.
You know I'm going to keep all this whole thing is going in. Look at this setup. I got 2 tracks going. This is the most professional I've been so far with this podcast. All right. So welcome to Device Squad, the podcast for the mobile enterprise from Propelics. Device Squad, fighting crimes against enterprise mobility worldwide. Bad UI, frustrating user experiences, poorly conceived mobile strategies, we defeat them all. This podcast series will cover all aspects of enterprise mobility, including strategy, development, design, testing, and more. My name is Steve Brickman. I'm a mobile strategist and UX architect with Propelics. First, a brief history of the company. Founded in 2011, Propelics is a mobile strategy consultancy helping enterprises worldwide devise true mobile strategies and develop world-class mobile applications across all industry verticals. Propelics clients include large companies like Amway, Bright Horizons, Bank of Montreal, Dubai Airports, Family Dollar, DLL, Cintas, Merck, and many more. Propelics' menu of services includes 8 different mobile kickstarts, covering everything from mobile strategy and road mapping to MCOE to UI UX design to mobile testing strategy, along with soup to nuts app design development and support. Additionally, Propelics offers 3 homegrown enterprise mobile products. Joining me today in the Propelics podcast studio, Andy Ofiesh.
Hi, Steve.
Now, Andy Ofiesh is a good friend of mine. Besides being a software engineer, he is a comedy friend of mine.
That's right. We know each other from comedy first.
Yeah, and intimately from comedy. Andy hosts the Naked Comedy Showcase at Improv Boston.
First Thursday of every month.
Have I been on the show? Maybe I have. Come down and find out. How's that? Good?
Yeah, that's awesome.
And coincidentally, or coincidentally.
Coincidentally.
Huh?
Yeah.
No one's used that one.
There you go.
He's also a software engineer for Bitcoin Armory, or at least you were.
Former.
Well,
formerly Bitcoin Armory existed as an
entity.
An entity. Now it's just the software is still there. Open source. Maintained by one of our developers.
And your brother is a founder of the Bitcoin Armory.
Yeah, Alan Reiner. He
Reiner.
created the application in his spare time while being a rocket scientist.
Oh, my God.
And he left that job to start the company once he got some funding. People wonder about the name being different. He's my half brother. We have different dads, but we come from the same motherboard.
Oh, okay.
Yeah.
So, Andy, why don't we start off? Just tell us about your digital journey and how you got to where you are today.
Okay. Well, my brother, he comes to me and he says, "Hey, there's this awesome thing. It's called Bitcoin." And I ignored him for about a year. So that cost me a lot of money. That would have been like late 2010, early 2011. He's a big crypto nerd. And he was on the crypto forums, and there was a lot of buzz about Bitcoin before anyone else knew about it on those forums, right? Mm-hmm. So then maybe a year later, it's like, yeah, I got this application. I put it together. Helps people keep their private keys secure. It's called Bitcoin Armory. And first he wanted me to put some money on his Kickstarter, and I did that. And then he's like, yeah, get into this project. It's really fun. It's a lot of cool stuff. You'll enjoy it. And I was like, all right, but I like being paid for the work I do. And then a few months after that, he got funding, and he said, well, I can pay you now. And he started a company, and then he hired me as his first developer. And then we hired a few more guys, and we had a startup, and 2 years later, we went under.
How about even earlier on? How did you get started in technology?
Oh, well, I would say for about 20 years prior to that, I was doing enterprise-level software for a number of different companies that then got bought out by other companies. So technically, I've worked at Intel, Juniper Networks, Nortel, And a lot of big companies where actually I was hired at much smaller companies that they bought.
Yeah.
So that's sort of my career.
Yeah.
Yeah. Work for a small company, get bought by a big company, move along.
Yeah.
But right now I'm at Harvard University. I don't think anyone's buying them out. I work on the Harvard alumni website. And I work on their making their website accessible, and soon we're going to the cloud, and a lot of service level stuff and maintaining their software offering for the alumni.
But we're here today to talk about Bitcoin and blockchain. So I've got a nice quote here, coincidentally from the Harvard Business Review of May 2016. The quote is, "The technology most likely to change the next decade of business is not the social web, big data, the cloud, robotics, or even artificial intelligence. It's the blockchain." Do you buy into that?
Well, what I buy into is really anything that is either Bitcoin or open in the same way that Bitcoin is open. What a lot of people are doing is they're taking that buzzword blockchain, which is a really good description of how Bitcoin is structured, and they're saying, well, now it's blockchain technology, and we can have our own blockchain inside our super big financial corporation or whatever application we want to have for it, or have like permissioned blockchain so that all the corporations in our sector can get on that and do blockchain stuff. But I feel like a lot of that stuff is really missing the point. The point is the blockchain allows individuals to connect with each other and do business without some trusted third party, which is, what corporations are for.
Let's back up a little bit. So what is blockchain?
Okay, so blockchain came about from Bitcoin, even though nowhere in Bitcoin is it say the word blockchain. Like the people that created Bitcoin and the inventor who wrote the famous white paper on Bitcoin, Satoshi Nakamoto, who's some person or a group of people that we don't know.
He's like Banksy, that guy.
Yeah, because, if you're an online persona, you don't know what's actually behind that. All right, so blockchain refers to any organization of data wherein there are blocks of data that get added on and cryptographically signed, and the signature from the previous block is included in the data that you signed for the next block. So you're chaining these blocks of data together in a chain of trust, and they all come out of some original source. In the case of Bitcoin, that blockchain is used to provide a public ledger of every Bitcoin transaction that ever took place. So that can be applied to a lot of different things. In some ways, you could think of, by some real loose definition, a Git is a blockchain because you have all these cryptographically signed changes to the state of your code repository in a Git. So that's more of a block tree. I mean, you really got to get loose with the definition, but most of the time people will assign the concept of the name blockchain to some derivation from Bitcoin, some variation on the Bitcoin protocol.
And the big aspect of it is that it's disseminated.
Right. So everyone can examine the signature and verify that the data in the blockchain is what it says, and it's independently verified, and that it was accurately represented, and nobody's given you some fake representation of the official data that's in the blockchain.
Help me understand the relationship a little more between blockchain and Bitcoin. Bitcoin didn't create blockchain.
Basically, Bitcoin, in the protocol and in the core development of it in the code, there's no reference to the word blockchain. It's just a really good description of it that someone came up with, and it turned into a buzzword. And then it became an umbrella term that referred to any kind of variation on the technology behind Bitcoin. So it's a real popular thing now. And what has happened in a lot of cases is a lot of banks that would like to inoculate themselves from the perceived disruption of Bitcoin to their business model, right? They say, well, now we've got blockchain. No, but not really. because the thing about blockchain is it doesn't do a lot of good for a bank, or it doesn't do a lot of good for like various financial services organizations, because the main thing that the blockchain allows is a lot of different people to trust each other with a public ledger without having any particular one of them be very trustworthy. So, right, banks have our trust. Or these financial institutions have our trust, even in cases where they shouldn't. But we all agree that we trust them.
Yeah. But this is peer-to-peer, and because of this duplication, even the most untrustworthy person can be trusted.
Right. Well, you're not trusting anybody. You're trusting the math of the protocol and the organization of it, and the self-interest of all of those involved in it, because there's a very strong economic incentive to play by the rules. You won't get paid if you don't play by the rules. So everyone's got a vested interest in that. And how do people get paid? So that's the other part of it I think a lot of people don't understand is missing from a lot of what people are calling blockchains these days. Blockchain doesn't do you a lot of good unless you have a value token that people put value in. And the most valuable value token in the blockchain world is Bitcoin. It's the largest store of value on any blockchain in the world. And without that value, what I call like a value layer, right, there's not much to blockchain without that. So when you talk about any blockchain other than the blockchain that has 90% of all the value on any blockchain anywhere, then you're not talking about much.
Yeah, so how is this value layer contrived? Like, how does it exist and actually have value?
Right. It really all started with a pizza.
Yeah.
So there's a famous pizza that was purchased online with Bitcoin, and it was something like thousands of Bitcoin. So in today's value, it would have been like a multi-million-dollar pizza.
Yeah.
But it was somebody on a crypto forum said, I want to try this Bitcoin out for real and see if I can buy something with it. And so sometime early 2010, they announced on the forum that they would pay 1,000 Bitcoin for someone in the London area, because that's where they were, to bring, and he put his address on the forum and said, bring me 2 pizzas and I will pay you this. And that's when the value of Bitcoin was established.
No kidding.
That was the first public transaction on the Bitcoin blockchain.
Maybe one of the dumbest.
Well, who would know?
Right, yeah.
My brother, when he started mining Bitcoin, he had thousands, like a few thousand Bitcoin, and a big chunk of that he just went and paid for all his mining equipment.
Yeah.
So I was like, great, now anything I make is bonus. But you use thousands of Bitcoin to pay for what you that would have been millions now. So anyway, so he's got that cross to bear. But who would know? You wouldn't know.
Nobody would know.
It was a bunch of crypto nerds playing with digital money, so you wouldn't know that everybody would get in on it.
Maybe it's off the subject, but I'd love to talk about mining a little bit, because I think the word mining is so weird.
Yeah.
In this context, I don't know what that means to be mining.
Well, so the combination of the blockchain, the value layer, the activity of mining is what makes Bitcoin special. None of these technologies, nothing behind here is much more complicated than math you can learn in high school or maybe undergraduate. It's really not esoteric math. What's esoteric about it is the invention that put it all together, right? So when people talk about blockchain, everything in blockchain is not that exciting. I mean, it's not that interesting. It's actually a very inefficient way of keeping data and verifying it. But it's necessary to work with the concept of a value token and mining in order to solve what's known as the Byzantine generals problem. So mining is, with all the other components around it, is the solution to the Byzantine general problems, which is what got a bunch of crypto nerds all excited when this white paper was released by Satoshi Nakamoto, which is why Bitcoin got popular. Because really smart people decided this is special, this has never been done before, this is life-changing technology. And then a bunch of people with money that trusted the smart people that got excited about Bitcoin got excited. Well, that guy's excited about, like, I know he's really smart. I mean, he's not going to fall for some stupid Ponzi scheme, right? He knows what he's doing. So he's excited about this technology. I'm getting excited about the technology. And then lots of people got excited about it.
In some respects, they were even smarter than the original guys that created it because
they knew what they were looking at.
Yeah.
Well, I mean, the person that created it had to know what they were creating.
Yeah.
It was a bunch of really smart people on these crypto forums that knew that this was an unsolvable problem. The Byzantine generals problem was unsolved. So let me explain this. And with Bitcoin, it's now solved. So with the invention of Bitcoin, this previously unsolvable problem became solved. So in a nutshell, the Byzantine generals problem is this hypothetical problem where you've got these Byzantine generals that want to attack the king. And we imagine the king lives in this huge castle. And there's 12 Byzantine generals. And you can imagine that they are all collected their tribes on 12 different sides of the castle at the points on a clock. So you've got your midnight Byzantine general, you got your 1 o'clock Byzantine general, all the way wrapped around. You know what I'm saying? On all the points on a clock, right?
Sure.
Now these guys were in ancient times, and they used really primitive forms of communication, like birds and stuff, or messengers. Smoke signals?
I don't know.
Who knows?
Just throwing that out.
Whatever. Right? So the idea is they want to kill the king, take over the castle, and form some kind of conglomeration and live democratically, suppose. I don't know. But they don't have good communication. They don't even really trust each other. They've been warring for years, right? They don't know if any of them are in cahoots with the king.
I see.
So the idea is they're only going to be able to take over the castle if they all attack at the same time, simultaneously. And it must be at least half of them have to attack simultaneously, right? Yeah. But how do they communicate the correct time to attack, right? Mm-hmm. So the idea is, what is a way in which they can communicate so that they can trust each other to set the attack time? And it turns out the solution is this thing called proof of work. And if they could just prove that they spent enough time creating the message, then it couldn't be faked. If enough time was put into, maybe they chisel it on a rock and strap that rock to a bird and fly it over and everybody can see this rock. I don't know. But the idea is this concept of proof of work will solve the Byzantine generals' problem. How can they trust each other to attack at the same time? Well, it's really the same problem. It can be reduced to the problem of a bunch of people on the internet agreeing on the correctness of a public ledger. And the concept of proof of work was invented to solve this. Now, what's proof of work? You have to prove work if you want to write on the public ledger, right? Yeah. So how do you prove work in computer terms? Well, you prove that you've spent a lot of energy and you spent a lot of money on your computer, right? And you solved a really hard problem. Well, solving that hard problem is what they decided to do was make hash. You hash all the data in the ledger. And that ultimate number, you got to understand hashing to get this. Hashing will take a bunch of data and convert it to a single number, right? And it's a concept used in a lot of aspects of computer science. Now, here's where they prove work. That number, which is a 32-byte number, right? Now, 32 bytes. And when you think about a 32-byte number, what I want you to think about is how many atoms are in the universe. That's about how big a 32-byte number is, right? It's huge. So we have to take all the data on the ledger, convert it to one 32-byte number, and in order to go into that ledger, that 32-byte number has to be really, really low. It has to be so low that only one time will the entire group of everyone trying to put information in the ledger, only once per 10 minutes will somebody succeed. Anybody, anywhere in the world. And once a week, they adjust the height of that number and make it lower and lower and lower as people figure out how to do it faster and faster and faster. So it happens only once every 10 minutes anywhere in the world. That number gets really low. The difficulty of generating a hash that low is measured in numbers of zeros that have to be at the front of that hash. It's like this limbo bar that can get infinitely low. I mean, really low, like a dozen zeros or more. It's more than that. I don't even know. There's got to be a lot of zeros at the front of this number. That's all I'm saying. And how many zeros is how difficult it is. And that difficulty is adjusted on a weekly basis in Bitcoin.
Yeah.
So every week, how many times was this all? Oh, we got to make it harder. We got to make it harder. So it's once every 10 minutes. And that's how that works. And so why do people want to enter an entry, a block of entries onto the public ledger? Well, they get rewarded. And that's mining. Right?
So does that block contain all of the Bitcoin transactions?
It contains all the transactions that went around on the network and a particular computer that created the block heard about. So if your computer is mining, right, it's basically going to hear about transactions from friends and friends of friends and friends and friends and connections and connections and connections. I say friends. I mean, whatever you're connected to on the network.
Yeah.
So all these transactions come across, and you get to put 1 megabyte of these transactions, and it comes out to about 7 per second every 10 minutes that can go in. That's about how many go in. And there's some complexity to that because transactions can be large or small. Large transactions have lots of inputs and lots of outputs. And then we'd have to talk about how transactions are represented in a block, right?
Yeah.
It's a bunch of ones and zeros according to the protocol, and you can look this stuff up. But the idea is you get about a megabyte of those, right?
Yeah.
And you hash it, and you're the lucky one that created that hash that's low enough to make it onto the public blockchain, right? And the idea is you try it, and you check it, and then you try it and check it again. And that is the speed of these mining computers is measured in trillions of times that you can do that in a second.
Wow.
Right? Trillions. So the idea is you're getting trillions of lottery tickets every second on your computer, right? So the numbers are crazy, right? And then they keep going up because technology keeps getting better and better and better. And the difficulty keeps getting harder and harder and harder, and more zeros you have to get, and you have to get luckier and luckier and luckier.
Wow. There's a really good demo that I found online, this Blockchain 101. I'll put a link to it on the Propelics blog for this podcast. This dude, Anders Brownworth, I don't know if you know who that is, but he...
yeah, I've seen him before.
Yeah, he just walks you through this process.
Of hashing, how hashing works?
Yeah, how hashing works. It's like a 15-minute demo.
Awesome, I'll watch that.
It goes through blocks and then blockchain and then distributed and then tokens and Coinbase.
Yeah, because it is really hard to just succinctly describe this. And I practice. I practice on my friends to their detriment. And then I apologize. I apologize to them for going down the Bitcoin rabbit hole, Well,
it's just really hard to visualize.
No, it is.
What this stuff means.
Some people call it solving a problem, and I call it like collecting lottery tickets.
Yeah.
That's the way I think of it, is the faster your computer, the more lottery tickets you can collect up. And each one is a lottery ticket because it's really random how low a hash can be, because it's effectively a random 32-byte number that you're picking every time you hash a block of data. And so that's why you can trust it, because nobody knows that they're going to be the one.
Yeah. Yeah.
So, and every time you try, it costs you money.
Oh, really?
Right. It costs money. It costs electricity.
Yeah.
And it costs upfront money to buy the latest equipment.
Yeah.
So it's all built in.
And so then if you win, let's say you have the lowest number.
Yeah.
You get Bitcoin.
You get Bitcoin. That's how Bitcoin are created.
That's how they're birthed.
Right. So the process of creating Bitcoin is also the process of validating a block of transactions.
Ugh.
It's also creating the trust. So these miners create Bitcoin for themselves. In exchange, they provide trust in the network. And in doing so, they solve the Byzantine general's problem.
Oh, my God. That's amazing.
Yeah.
But Satoshi Nakamoto,
Yeah.
he didn't come up with mining, though. right? He just
Well,
came
it's
up
built
with
into the protocol. He literally mined the first, I don't know how many blocks for 6 months.
Oh, he did. Okay.
Well, because he created Bitcoin, obviously before anyone was using it, right?
Yeah.
Before anyone knew about it. If you can look at the blockchain, the Bitcoin blockchain, you can see all the empty blocks at the beginning that he created that nobody was using. And then the transactions slowly start trickling in. People start testing it, try doing stuff. And at that point, Bitcoin wasn't even worth anything. And there are a lot of Bitcoins mined in those early blocks, right? That only the inventor, Satoshi Nakamoto, has any access to, if anybody. He may not even have access to it. Who knows what he did with the private key?
Yeah.
He could have burnt those private keys. He could have just threw them out.
Yeah.
Who knows?
Just for security.
Yeah,
safety.
yeah. And you can go into a lot of those early blocks with people testing on. You can see actual Bitcoins that are irretrievable, provably irretrievable, which is interesting too. You can go in there and look at the early Bitcoin blocks in the blockchain, and you can see some interesting stuff and learn a lot of it. The rabbit hole goes deep, is what I'm saying.
It's deep. So another term for Bitcoin is what? Distributed ledger? Is that right?
Yeah, it's distributed, right? Because copies of the ledger everywhere on the internet.
So one thing that I was wondering is like, how big is this thing gonna get? Like, does it just like grow in?
Oh yeah, it's always going to grow.
So like terabytes and terabytes. Like, is it just gonna continue growing like? Forever?
Yeah, well, the data on the blockchain is pretty compact compared to lots of other things like video. I'm not sure the numbers. I mean, you can basically download the Bitcoin software and run it, and after a while, it will produce all the blocks on the blockchain locally on your computer, and then you go into that directory, and you see how big it is. I wouldn't even guess how big it is at this moment. I mean, I remember at some point, I remember thinking, all right, I got to get a new hard drive.
Yeah.
You know what I mean? Like 256 gigabyte hard drive's not covering it anymore. I better have 500 gigabyte.
But of course, hard drives just keep getting bigger.
Yeah.
And
Yeah.
So the technology just evolves along with it.
Yeah. So it's not quite a terabyte yet. It's some hundreds of gigabytes, I think. Maybe 100 gigabytes. I'm not sure. It's on that order.
So this is just the definition from Wikipedia. Blockchains are secure by design and an example of a distributed computing system with high Byzantine fault tolerance. Do you know what?
Byzantine fault tolerance is those Byzantine generals. They had to worry about a bad actor coming in and telling them the wrong time to attack. So what that means, that Byzantine fault tolerance is, can somebody trick you into thinking that the blockchain is different than it is?
Okay.
Can somebody come along and provide you with a spoofed copy of the blockchain, trick you into thinking you're paying somebody or not when you're actually paying them? Or they can trick you into doing a transaction that didn't really happen because you're not actually on the correct blockchain, and then you give them the thing that you thought they paid for, and they didn't actually pay you.
Right. So all those problems are impossible with blockchain.
Right. Well, I mean, assuming that you're not an idiot and just trust somebody to tell you what the blockchain is.
Maybe we should talk just briefly about how blockchain prevents the double spending problem.
Whew. Okay, double spending. So without this trusted public ledger, right, you can say, I pay you some money for a thing, and you give me the thing, and I'll use the same value tokens on the internet and pay somebody else at the same time for a thing. And maybe I'll do that a dozen times, and I get 12 things for the price of one. Now, if that thing is a car, I got a whole fleet of cars now for the price of one car. And I take delivery of all these cars simultaneously. They all show up on my doorstep. And I got all these cars, and maybe only one of the people I paid for actually received the digital tokens, because I used the same digital token 12 times.
Okay.
Right? So what happens is on Bitcoin is you typically will not deliver the thing that was paid for until you see confirmation independently on the blockchain. And what happens is every 10 minutes, a new block gets put on top, right? So you wait in about an hour so that 6 blocks can get piled up on top of the block with your transaction in it. And then you can feel really secure, right? Because what happens is the official blockchain is always the longest blockchain that is cryptographically provable. In other words, somewhere in the world, 6 different people in the quickest amount of time provided the lowest hash, proving that they did the work on the blocks, and there's 6 of them, right?
Right.
So the only way a double spend could happen is if I'm some sort of mad genius that created the fastest Bitcoin miner in the world, and while everybody else in the world was creating 6 blocks, I created 7. Mm-hmm. And then I unleashed my 7 blocks on the world, and everyone's like, oh, wow, okay, hold on. This is longer, and they've got 7 crazy low signed hashes, right? And now we got to go by this guy because he had the last 7, much faster than our 6 even. So now everyone follows the longer blockchain. And on that blockchain, I still have my money that I paid for that car.
Right.
I could pull that off, right? But the amount of money I spent mining those blocks, way more than the cost of the car.
Yeah, right. So
I'm like super genius level and I'm like Goldfinger in one of the James Bond movies, right? I mean, for that kind of money, I could do a lot more than cheat somebody out of a car.
Right.
Which is why, you wait 6 confirmations, then go ahead and deliver the guy the car that they paid for with their digital tokens.
And 10 minutes is like an average?
Is average, right? There's a bit of variance on that.
Yeah, okay. And that's the average for how long it takes somebody to find that next lowest number.
Yeah.
And that lowest number is the hash. And the hash, it represents
a cryptographic signature of all the data on the blockchain.
Yeah. Okay.
Right?
Yeah.
So somebody could take their copy of the blockchain with your hash and prove that your version of the blockchain is my version of the blockchain. And that's provable. Because I'm going to hash that data the same way you did, and I'm going to get the same thing, and I get that same number, that same super low number that you got, and it's like, oh, this is it. This is the actual data. Because if there was any variation, I would get a different number. It's just that when you put a new block of data on there, the hash you get won't be included in the public ledger unless it's low enough.
Yeah. Well, I see. So at what point do you say, like, okay, that's the lowest number?
Well, as long as it's low enough to beat the difficulty. As long as it's got enough zeros on the front of it. Yeah.
Oh, I see.
And it's the first one. It's the first one to get in there.
Yeah, yeah.
It's the earliest one, because then somebody else is building the next block off of that.
It's like gamified, kind of, right?
Totally
it's
gamified.
Like, which was my last podcast. It's so incredible.
Yeah. By the way, and here's why I have a lot of judgment when people talk about blockchain without Bitcoin.
Yeah.
They're talking about this way of signing data and including it in a public ledger that has lots of useful purposes. But if you're not running this gamification public, there's better ways to do that.
Yeah, I see.
There's better ways. You could just have cryptographically signed data in a relational database. You could just have this in some kind of much more efficient database that serves the purpose of your business.
Yeah.
Right? You just have a scheme of providing signatures for the data on a regular basis that people can look at and assess, and have the data out in the public, and people say, yep, you signed it. This is correct. This all adds up. It doesn't have to be in a chain of blocks.
Right.
It's only in a chain of blocks because that's the game we're playing in mining Bitcoin. And without the rewards, why are we even doing this? Why is anyone mining anything without the reward? And 90% of all the rewards in the world are on one blockchain. So really, as Andreas Antonopoulos famously said, he's my favorite Bitcoin guru, without Bitcoin, there's no blockchain. And now Bitcoin has some competition. I mean, there are some other blockchains out there.
Yeah.
Ethereum is the second most popular at the moment. And there's a few others in the top, say, 5 to 10, which have a significant chunk of the other 10% of the value that Bitcoin does not have.
Yeah.
Dogecoin, that's one. Even though they're way down on the list in value, but they're famous because they use the Doge meme.
Oh God.
And all of those that are doing proof of work, along with Bitcoin, without those, there's no blockchain.
But they're essentially just duplicated Bitcoin. Is that
With
kind of what you're saying?
variations.
Yeah.
You know, there's all these blockchains decide, oh, well, Bitcoin doesn't do this good enough. I'm going to make my own blockchain that does it better. So, well, we'll see if yours is better, because eventually, over time, if it has enough value in the improvement over Bitcoin, then it will eventually, its value will exceed Bitcoin. And the closest thing to that is Ethereum, which has sucked up about 10%, I think, somewhere on the order between 5 and 10% of all the capital in blockchains is in Ethereum. And now, where Ethereum is somewhat more advanced than Bitcoin is they've just done a lot of stuff that allows you to be more creative with how you work with it. It adds a lot more features, but less security. Mm-hmm. And Ethereum has had some famous missteps on security and integrity in their blockchain. So I could go into much more depth on that, but that's a bit of a tangent.
Maybe for part 2.
Yeah.
So how is the value of Bitcoin determined? How does the value rise?
It's what people want to pay for it.
Okay.
That's why Ethereum is the second best, because it's got a lot of exciting features that a lot of crypto nerds got excited about. Yeah. And then the people that know them, they go, well, that guy's excited about it. I'm excited about Ethereum. And then they're like, well, I better buy some in case it becomes the next big thing. That's where all the value comes from. Is people getting excited about the invention.
And where do you buy Bitcoin?
You can go online. There's services. I won't even name any of them.
Yeah.
Because I feel like all of them really pale in comparison to my favorite way to acquire Bitcoin is to get it from somebody you know. Either do a job for Bitcoin, provide a service for Bitcoin, provide some goods for Bitcoin, or offer to collect money for a charity that you like. Mm. You know what I'm saying?
Yeah.
And then receive that money in Bitcoin, pay cash the charity. Mm-hmm. Huh? Yeah. Now you've got your Bitcoin.
Yeah.
And you've paid a bunch of cash to a charity.
Nice. That's good.
You're paying that charity for Bitcoin that you're receiving from your friends.
Right.
It's all even Stevens.
Right.
But now you've got Bitcoin to play with, and you didn't have to go through some third party, right, that you trust to sell you Bitcoin, because the whole point of Bitcoin is it's peer-to-peer. You shouldn't need a third party.
Oh, I see.
And yet a lot of people go to these third parties and they buy their Bitcoin because half that transaction is fiat, is half of it is some cash in whatever your local currency is, and then you need that third party to pay that cash and trust them to give you Bitcoin for it.
But isn't it the third party companies that are sort of helping control the value?
Well, they're setting the value based on what people will pay them.
Yeah.
And what people are accepting in local currency for their Bitcoin when they sell it back to that third party.
Right.
So the third party is not deciding. The third party is like, hey, you guys decided, and there's various ways in which that's being reported and stuff, and it's whatever's going on in the open market, So people decide how much a Bitcoin is worth collectively. We all do.
That's kind of part of what makes it so amazing is that it works without a central authority.
Oh yeah. There's no central authority. I mean, there are central authorities within the Bitcoin economy, right? There are these third parties that everyone trusts that you can trade Bitcoins with, and people will go that route. But to me, you're not really using Bitcoin unless you're doing it peer to peer, individual to individual.
Yeah. So one other statement here, more from Wikipedia again. This blockchain technologies offer a Stigma G approach, allowing us to achieve large scale.
What approach? I'd have to see that written out.
Systematic cooperation in an entirely distributed and decentralized manner. They can be considered as hyperpolitical and global governance tools capable of managing social interactions on a large scale and dismissing traditional central authorities. Blockchain governance may allow human beings to evolve to a Stigma G age.
I don't know what Stigma G means.
With leaders without orders, order without law, and communities without borders.
Well, let me tell you, one of the things that I don't know if it speaks to that concept, but one of the things, again, this is an idea definitely popularized by Andreas Antonopoulos. I don't know if he's the one that came up with it. I think he was quoting someone else, but Bitcoin has the potential to end war. Because when nations go to war, historically, the only way you can afford to go to war is to print money. You really gotta do something to your currency to generate the funds to pay for that. Well, if everybody uses Bitcoin, right, it will devalue every nation's currency so that they can no longer afford to pay for war.
Interesting.
Isn't that amazing?
Yeah, that is amazing.
And anyone that bought Bitcoin now will be very wealthy.
Right. So Stigma G, if I'm even pronouncing that correctly, is a consensus mechanism of indirect coordination through the environment between agents or actions. The principle is that the trace left in the environment by an action stimulates the performance of a next action by the same or a different agent.
Wow, that word is so fancy. I'm having a hard time understanding the definition.
That is a really fancy word.
Okay. Well, I'm going to have to do some research on that. I learned stuff just learning about Bitcoin, by the way. That's not unusual.
My God.
That's not unusual. People will often get into online discussions about Bitcoin, and in the process, they'll realize, well, they actually not only don't know much about Bitcoin, they also don't know much about actual currency. They don't know much about various policies that they think they knew. Yeah. And in the process of acting like you know something, you actually learn stuff. It has inspired a lot of discussion about some weighty topics that people thought they understood, but really only understand after discussing Bitcoin.
So who are the central authorities that we're talking about?
Well, anyone that you trust in government, large institutions. I mean, you realize who you trust when suddenly there's a mechanism wherein you don't have to trust.
I mean, isn't currency already just sort of a random agreed upon value?
Well, national currencies, the value comes from their acceptance for taxation, right? So, you live in the U.S. and you make money in the U.S., you have to pay taxes. Or you have to come up with a good reason why you don't have to pay taxes.
Right.
And that in itself costs money.
Yeah.
So the reason we have a certain value on dollars is because they're accepted by the government to pay your taxes. So that's where that value comes from. I mean, that's where it originates, and then from there, it's whatever we agree it's worth, I guess, denominated in other currencies. So it's everyone, again, collectively agrees, say how many euros a dollar's worth. But then how much is a euro worth? So some wealthy nation is accepting taxes in some currency, and that's how much that currency is worth.
I think the most interesting aspect to this discussion is the fact that you're telling me that blockchain is really, at least ideally suited for Bitcoin and these sort of digital currencies, and that everything else is maybe a lot of hype.
It's a lot of hype. These banks are being threatened with the blockchain revolution. And they think, right, that, well, we'll just use blockchain and then we won't be taken over. But it's not like that. Because banks already paid to solve the thing that blockchain solves by being a big bank.
Yeah.
Right? It's almost like taxi cab drivers cannot just join Uber to resolve the issue that Uber is taking over taxi cab driving, because they already paid for their medallions.
Yeah.
They get to drive a taxi because they went through all the hoops
to
drive the taxi. Now Uber came along and has a bunch of drivers that didn't go through any hoops.
Yeah.
They just have to get their rating up above a certain level or else they can't drive for Uber. So they just changed the game. That's what's happened, is Bitcoin changed the game.
That's
right?
a great analogy.
Now, if everyone starts playing the game, then the banks are screwed. Well, not everyone started playing yet.
Yeah.
The game's not ready to be played.
Right.
Bitcoin still isn't ready for prime time.
Yeah.
All of the software built around Bitcoin and the other blockchains with a value layer, one of the things I discovered working at Bitcoin Armory is when we went to these enterprise level, that's what we were trying to do, is create enterprise level security around Bitcoin.
Yeah.
For companies and organizations to use them. And what I noticed is they weren't interested in any of it. Because for enterprise level software, for these big financial organizations, for them to use Bitcoin, they need real software that has proven security, right?
Yeah.
And what they see is a bunch of toys.
Yeah.
They're like, you want us to run our organization with those toys?
Mm-hmm.
You got to be kidding. They see Bitcoin itself as a toy.
Mm-hmm.
And it's a bunch of people using what they perceive as a toy.
Mm-hmm.
Right? So,
I can see that maybe.
yeah.
Like the idea of mining might seem kind of hokey to them.
Yeah.
Or,
But again, it's not for them.
yeah. Right.
They're major organizations.
Right.
They have trust. You know? They built up this organization to live in this world where all these big corporations interact with each other.
Mm-hmm.
And it's the size, right, that creates trust. And it's the size of your organization. And then, of course, that trust gets violated on a regular basis.
Yeah. Right.
And yet we still trust them because on average, it works out okay.
Yeah.
On average, you know, with some spectacular failure.
Yeah. Of the last few years.
Right.
Yeah.
But it's old technology. And
Yeah.
eventually, Bitcoin's never going to get uninvented.
Right. Yeah.
The software built on Bitcoin and the other blockchains in that space, on the other public proof of work blockchains, is only going to get better.
Right. So
It's only going to become less and less like a toy.
yeah.
And that progression takes time. And it's not done yet by a mile.
Do you have a prediction for how long you think it's going to take before it becomes mainstream? I mean,
I don't know, decade?
yeah.
I don't know. How long did the internet take? I mean, it's been around.
Yep. 20 years.
I mean, you know, you think about how long the internet took to become mainstream from
Yeah.
when it was a way for research institutions to communicate and to do work for the Department of Defense, right?
Right. Yeah.
A secure way that could withstand even a nuclear attack. That was the big appeal for the internet. It was distributed. You know, you could blow up the Pentagon, the internet will still be there. And the research will go on, and these organizations can continue to communicate. Everyone, you know,
Yeah.
is distributed, right? And just like with the internet, you know, it took a while to go from just research institutions and a bunch of nerds to everybody using it. You know, it was like from late 60s, early 70s up until mid 90s. Wow, that's about 20 years, right? So if it goes along the same progression, then we're looking at 2028.
So we know that Bitcoin is not going anywhere. Can't go away.
It can't be uninvented.
Can't be uninvented, and it can only get better and more secure, more
As more
usable.
people build on it, or something better like Ethereum, which people already perceive that as better than Bitcoin, and others don't.
But still, it's still a peer-to-peer currency. And
Yeah.
I mean, is there a chance that the government could step in and say, like, hold on, we don't want any of this happening, and just ban the whole operation?
How?
Just shut it all down.
How?
I don't know.
All they'd be doing is excluding themselves from the blockchain. We don't want to have anything to do with that. All right, fine. We'll be fine without you.
Well, I mean, can they somehow declare it valueless, or somehow say, like, you know,
it's a First Amendment right. It's
Yeah.
a public blockchain. It's a communication of an agreed upon public ledger
There
of all
you
the
go.
transactions that have taken place. So you're basically saying we don't have freedom of speech if you
Right.
do that.
yeah, it would become a First Amendment issue.
It very well is a First Amendment issue because all it is a communication of public data.
Right.
No one has to give it any value.
Right.
And yet we all do. We've all agreed at this moment it's about $1,200 for a Bitcoin, which is a crazy number. If you got started in this early, it's hard to wrap your head around the fact it was only a few years ago it was worth a buck, and only a year before that it was worth a penny. I mean,
I remember that. I know.
And before that, it had no value because it was just one guy or one group of people. Like, look what we created.
So I'm just starting to see the true magnitude of blockchain.
Yeah, yeah.
So let's just go over some of these because this is a mobile enterprise podcast. So let's just talk about some of these use cases that are being explored here, and you can tell me why they're just like bullshit. Okay. So Maersk and IBM are bringing blockchain to the global shipping industry. So this was on website psfk.com, and they said that IBM and Maersk, the world's largest container shipping company, have come together to create a digitized supply chain pilot. This program will help manage and track the paper trail of tens of millions of shipping containers traveling the globe.
All right.
So why isn't blockchain an appropriate technology for that application?
Well, you got to ask them, what's your value add? What are you getting out of that, right? So it's a buzzword right now. There's a lot of trade-offs in that application space, right? There's performance, there's communication, there's trust. Now, there's blockchain. You got a bunch of signed blocks in a chain, and you can independently verify those signatures and the data. And you can distribute that data, and it can be on a public record that anyone, you or I, could look at, and we can check the signature and make sure that we're looking at the actual record of their world, right? Their little application space. Anyone can look at it. Great. Is that the most efficient way? If you're not doing proof of work, and you're not involved with you don't have some value layer involved, is there a need to do it in the form of a blockchain? I don't know.
Yeah.
Well, we'll see. Maybe they'll start out there. Now they're outside the box, right?
Yeah.
And from that, maybe they'll come up with a better way to do it.
Oh.
Huh? Maybe. Who knows? It's in trial. See what happens.
Yeah.
I don't have a lot of faith in it.
Yeah.
But we'll see what they come up with, and then it'll be exciting. Here's the thing. Don't bother me with your crappy little private blockchain project until you actually release it upon the world and show some value. What is the value in it? What's the value add? Why are you doing it that way? Let's see it work.
So
until that happens, I don't have the bandwidth to consider it.
At this point, it's almost they're just trying to create buzz.
They're creating buzz on their little idea, and they're saying, hey, we're involved in the blockchain.
Yeah.
Blockchain revolution is not going to take us over.
Yeah.
You know what I mean? It's sort of like you drive a taxi, and now all of a sudden you've joined Uber. Sorry, you had to pay for that medallion. Sorry, you had to start IBM to come up with this.
Yeah,
I don't know.
So this one is even more confounding. I think this is from Conduit Hub. Indeed, some of the biggest opportunities are within marketing. These marketing people are always trying to jump on the latest and whatever it is. Developing customer-centric propositions and relationships that empower and motivate customers while also delivering massive efficiencies and responsiveness. There's a lot of big words in there.
Great. I'm sure you could get some massive efficiencies, but you're already starting at a detriment when you put all your data in a blockchain because that's automatically a little less efficient,
right,
than what you could be doing. So less efficient in some ways, maybe I guess more efficient in other ways. I don't know.
Yeah, and then they talk about how blockchain can be used for the transfer of promotional points from person to person, and how blockchain can be used for incentives, rewards, and promotions.
Well, see, here we've had rewards programs forever, right?
Yeah.
Without the blockchain. So is your blockchain going to make some airlines rewards program more efficient by putting the data on a blockchain. I don't know. I call JetBlue. They tell me how many points I have, and I trust them. So they could put it in a blockchain. I'm not going to trust them anymore. I don't know why. Maybe all the airlines could get together and have a combined loyalty reward. But then why even do that? The whole point is to get people to fly your airline, not the other ones. So what the hell? Explain it to me. That's the thing. Great, blockchain. How are you applying it to this application space? Be more specific. What are you getting out of this technology?
The last thing they want to do is create another currency of points.
Right. Do you think JetBlue has any interest in doing this?
Right. So what you're saying, the whole benefit of Bitcoin and the blockchain is that it eliminates the central authority. So therefore, it's totally inappropriate to think that enterprises will adopt blockchain because they want to be a central authority in some capacity.
Right.
Either doling out points and giving out rewards and incentives, promotions, whatever. They still need to hold the authority.
Right. So what's happening is this technology is threatening to disrupt these organizations, and it's not for those organizations. It's not for you. I'm sorry. It solves a problem that you already solved with older technology by being a big corporation.
Right.
You're the king.
Yeah.
The king does not need to solve the Byzantine general's problem. The king is only the victim of the solution without any ability to apply the solution. The king is not interested in solving the Byzantine general's problem. It just hopes nobody solves it.
So do you think that Wall Street is concerned? Like, how will this affect the market overall, do you think? Or will it affect the market?
I don't know. I have no idea. Yeah. I wish I did. I would be shorting some stocks right now.
Yeah, that would be good.
Or I'd be buying them. I don't know. We'll see. It's exciting. Here's the thing. It's still an experiment. Who knows? Who knows what could happen?
So some additional advantages of blockchain. Protects individuals' rights through immutable records, enables a true sharing economy.
Yeah.
And then one that, this is all from TED Talk that I found on by Tapscott.
Yeah.
One that I hadn't thought about is that it ends the remittance ripoff. And so what is the remittance ripoff? Well, that is the fact that Western Union will charge 10% for you to send money back to your family in the Philippines. $600 billion a year is being sent this way to families in other countries. And blockchain can undercut this. Abra, this company that I have up here at goabra.com, they're actually using Bitcoin though, right? And they charge 2%.
They charge 2%. Basically, they're doing Western Union over Bitcoin.
Right.
Right. Here's the thing, right? The 2% they collect is so you and your relative in some third world country don't have to learn how to use Bitcoin.
Exactly.
That's their 2% cut.
Right.
They're saving you from learning that.
Yeah. Yeah.
However, you and your family member in a third world country could just learn Bitcoin.
Yeah.
Get a simple app. Apparently, a lot of third world countries, as they're becoming more affluent and gaining some income and getting some technology, they're going right to the mobile, right?
Yeah.
They're skipping all the infrastructure that they can't afford yet. Go right to mobile. Well, mobile, perfectly suited for using Bitcoin.
So what I see happening is Abra charges 2%. Another company is going to come out and then, well, we don't need to charge 2%. We could charge 1%. And then another company is going to charge 0.5%.
Guaranteed.
Right?
There's a guy on a corner charging 0.25%.
Right.
Doing whatever. And maybe charging more because all the people in that guy's neighborhood know him and trust him. That's the guy they use to change money anyway, right? Because every repressive country has guys on corners exchanging money. And, black market, right? That's what oppression breeds. Well, there's a guy on a corner. Pretty soon that guy on the corner is going to be able to do stuff with Bitcoin.
So here's a couple ones that I didn't really quite understand from this TED Talk. He says that blockchain will ensure compensation for intellectual property. So like songs, pieces of writing, inventions, and that intellectual property will sort of become its own business entity.
Yes.
All right. So you
Yes.
sound like you understand that better.
Oh, absolutely. It's one of the many applications. In Bitcoin, right? You can prove that you own some content and you're selling it on Bitcoin. You can enter into the Bitcoin ledger a hash of some data that proves you invented that data. That can be done. That can be very easily done, and applications will be built that can do that. So ultimately, what the user experience will be is, let's say I really like a particular artist, right? And that artist has a website with all their content, and on that website, they have a QR code with their Bitcoin address, and I can shine my phone at that QR code and pay them Bitcoin directly for all their content or subscribe to it. And they can run an app too and make sure they get paid. And that app can also prove that they created all of the content on that website.
Mm-hmm.
So I can then examine the proof and was like, you didn't steal any of this, did you? There's proof. And I'm buying it from you. And I know you created it. And all of that can be answered using apps on the internet. And you simply have to just download and use these apps as an artist and as a consumer of art. And the money you pay goes right to that artist with no middleman. Except maybe $1.99 to pay for the apps that you guys all got.
Can blockchain be used to prevent identity theft?
Certainly. But everyone's got to be using it.
Right.
Here's the thing, right? All these applications, these are great applications, pie in the sky applications.
Yeah.
None of them are going to do much until everyone's using it.
Yeah, right.
Right? All these applications come with mainstream adoption. You know, here's the thing. Bitcoin solved this big chicken and egg problem, right? It is a big chicken and egg problem. And within that chicken and egg problem, there's more chicken and egg problems.
Yeah.
Right? All these apps aren't going to get built until there's mainstream adoption. But why would there ever be mainstream adoption unless these apps get built?
Yeah.
Well, it's a slow process.
Yeah.
This is why it's not going to be mainstream until basically about 20 years after it's been invented. It's a slow process, you know?
Yeah. The prevention of identity theft could be a strong motivator.
Yeah.
For people to get on board.
But here's the thing. You're not going to build that app until it's mainstream adoption. There's not going to be mainstream adoption until you're going to build that. You know, one of the things that is also going to happen, which is exciting, is there's going to be virtual economies.
Yeah.
So what will happen is there will be programs on the internet that have Bitcoin, where this program is an entity that owns Bitcoin.
Yeah.
And the program itself will fund crowdsourcing of features to itself.
Oh.
Huh?
Wow.
Yeah. Self-funding development of itself.
That's pretty crazy.
And these programs will communicate and pay each other for services. Software as a service is a whole thing, right?
Yeah.
Programs are going to start paying each other for services that they use to provide services to other programs. There's going to be a whole virtual economy beyond human control.
Wow. Wow.
But again, none of that's going to happen until there's mainstream adoption.
Yeah.
Because it's going to be an economy of scale. Like, here's the thing: these programs are going to be usable by everybody, and it's going to be in everybody's use that they will have the power to fund themselves and crowdsource themselves to become more powerful.
I wonder if AI will have some crazy influence on this virtual Bitcoin economy that happens.
Well, don't get me started on AI. That's a whole other rat hole.
Yeah,
it's a deep rabbit hole, and the more you understand, the more you realize you were wrong yesterday. And that process is still ongoing for me. All right. So if anyone's hearing what I'm saying and think I know what I'm talking about, please independently verify anything I say. And that's worth doing. That's worth doing just for your own edification.
right. I don't have any disclaimers
good.
myself. Maybe we should get one.
Yeah.
But here's some really awesome quotes I thought that helped sort of summarize how the impact of blockchain, how large it might be. Think about the blockchain as another class of thing, like the internet, a comprehensive information technology with tiered technical levels and multiple classes of application for any form of asset registry, inventory, and exchange, including every area of finance, economics, and money. In fact, it is even more, the blockchain concept is a new organizing paradigm. That's Melanie Swain from something called the Institute for Blockchain Studies. Now, it sounds like maybe you don't quite buy it.
Yeah, again, it's not that I don't buy it. It's just it's hard for me to follow exactly what's being said. It's just so many of these things. I'm sure they know what they're saying, but with so many words, it does tend to get into territory where it's like, it's open to interpretation.
Right. Some jibber jabber. So I had some of the strategists put together some questions.
Oh, great.
Do you see smart contracts being used with blockchains by companies? For example, simple software programs that run across all nodes in the network and can extend the validation logic at each node in a way that is automatable and undeniable.
Smart contracts is another one of those great buzzwords that is really kind of ambiguously defined. Now, that's one of the things that people get excited about with Ethereum, the second place runner-up to most valuable blockchain at the moment. And smart contracts is one of the things I got all excited about. Now, here's the thing that Ethereum does is put the whole fancy contracts in the same layer with their protocol.
Mm-hmm.
Bitcoin has all the components needed to make some really basic contracts. And there's a lot of restrictions on what can be done because with more complicated contracts comes an increase in the amount of time it takes to validate the transactions, which is part of the process for validating blocks, right? And how the network works, right? Because you have to validate every transaction before you pass it to the next node in the network, right? And if the contracts get too complicated, then the time it takes to validate goes up. And you open yourself up to denial of service attacks, right? And things can get complicated, and there's ways that your network can be attacked. Well, Bitcoin tries to protect itself by severely restricting how complicated your contracts can be. Mm-hmm. So where I think all this is headed is there will be the value layer, like in Bitcoin, and then some very basic contracts that you can do, right? And from there can be a whole other layer on top of that has more complicated contracts. And so you build layers. Here, that's one of the ways in which Bitcoin as a protocol needs to grow, is you don't want to make the protocol more complicated and reduce the security in the value layer. What you want to do is have a really solid value layer with limited ability, and then build all the complexity in another layer on top of that. And that's an ongoing process.
Yeah.
Right? And there ultimately will be a whole protocol stack. And what we're seeing now in Bitcoin is this thing called the Lightning Network. And that is based on a feature they're trying to get adopted in the Bitcoin protocol called segregated witness, right? And they can get segregated witness adopted in the protocol, and then you can build the Lightning Network on top of that. That's going to be like a really fast transaction layer. Mm-hmm. That's going to sit on top of the value layer of Bitcoin, right? So now you get your transaction layer. And basically the way the Lightning Network works is you got pipes, right? So you create a pipe with a transaction on the Bitcoin layer, and now you got that pipe, and you've got pipes going from all these different entities, and you can shoot Bitcoin through those pipes instantaneously without having to wait for confirmations, without waiting the 10 minutes, right, for a confirmation. So that's a layer. That's like transport layer almost, to try and reuse some internet terminology. But here, once you get the transport layer going, right, then if that's in there, then you can build layers on top of that. And layer upon layer, and in there you get all of the complex contracts that you could want to create on top of that. Anyway, here's the thing. The Bitcoin value layer doesn't have to change. You want to keep that nice and secure because that's where all the value lives. So that's where I think this is headed. There's going to be layer upon layer upon layer. And if Bitcoin doesn't support that kind of protocol stack, what's going to happen is that eventually we'll be overtaken by a better version that will support that kind of stack. And it could be Ethereum, or it could be something else. We don't know yet.
How about utility in healthcare? So this was another article about blockchain by Ted Tanner, who claimed identity management connected to eligibility and benefit verification will be one of the first applications as blockchain makes its way into healthcare. Oh, and transactions that occur are a function of hashed values that are reliant on the previous transactions. Thus, the entire provenance or identity of that transaction is fulfilled. So, do you think that blockchain has value in healthcare?
Well, it could. And again, that would be what we call the applications layer, right? Yeah. So you got your value layer, and then you have your little transport layer that people are trying to get on top of the value layer there. And then on top of that, maybe you got your contract layer. Or maybe in a whole other stack, right? You've got an application layer. And that application layer sits somewhere on top of the layers below it and creates healthcare applications on top of the underlying trust layer, the value layer, the ability to transact quickly and easily, right? And all of that will be pinned down with a provable public record of who's eligible for what.
Yeah.
You can also use things that are being created right now. There's a concept known as zero knowledge proofs, right? Where you can prove data while keeping it secret, encrypted. You know, Bitcoin uses encryption, but only really uses encryption for validation. It doesn't use encryption to encrypt the data. All the data in Bitcoin is the data in Bitcoin unless you encrypt it separately and somehow stick it on the blockchain.
Yeah.
It doesn't actually do the encryption. You have to do encryption to, say, secure your private key, which we haven't even gotten into private and public key yet. But a lot of encryption is used around Bitcoin, but Bitcoin itself doesn't use encryption to encrypt anything. And there are some other Bitcoin alternatives that use zero knowledge proofs where you can validate data that you don't even know until somebody tells you that data. And that could be very useful for healthcare because of the HIPAA constraints on healthcare data, right? So perhaps on some blockchain that uses zero knowledge proofs could be the underlying layer on which a healthcare application sits.
And then there's also this idea that you could store records somehow and then prove the identity of the records. Large healthcare files such as imaging scans or PDFs wouldn't need to be stored entirely on the chain, but could be linked to it with a hash or a cryptographic numeric fingerprint.
That's right. You store the proof of the data on the chain.
Yeah.
So then I provide you with the data and the signature, and you find the signature, right? You find that on the chain, and you know the data that is true, and then I share it with you.
Yeah. Yeah. I mean, in that case, it seems like there's enough value that the idea of proof of work may be applicable, or
you would have to have proof of work as part of the value layer in order to prove any of this.
Yeah.
Because without the proof of work, well, I can just create any old blockchain I want and have the data in there that I want. I haven't proved any work, so why is your blockchain any better than my blockchain? No, my blockchain is the blockchain. Prove it. Prove the work, you know? And you're not going to prove much work without a value token. Because how are you rewarding all that work?
Now you make me feel bad that I haven't asked about public key and private key, but what are those? Should we talk about that?
Well, that's a whole other direction to go into, which is basically how you, as a user of Bitcoin, prove that you're able to move the funds that are reported on a particular row in this public ledger.
Okay.
So every row in the public ledger has a public key that says the person that has the private key that goes with this public key in their possession and can prove it can spend that money.
Okay.
Right? So this is where also you're forcing me to remember all of my private public key cryptography knowledge and what everything is called, right? Because
you brought it up.
It goes deep. Here's all you need to know.
Yeah.
I have a private key and a public key. I keep the private key secret. I tell everyone my public key, right? And they use the public key to verify I own what I said I own, and I use the private key to prove that I own it.
Okay.
But if anyone else sees my private key, well, then they own it too. then they own it, and then they can spend it.
Yeah.
So this is where encryption comes in. I have to keep my private key really secure, offline.
I see.
Cold storage, encrypted,
like on a thumb drive.
Yeah. No, so it goes deep, and this is the software that I used to create. I used to help create with my brother.
Yeah.
You know, it's what he invented was Bitcoin Armory. It's a way to store your private keys offline and use them at the same time. So anyway, if anyone's curious about that, look up Bitcoin Armory. It's open source code that is still being maintained by one of our developers whose online moniker is Goat Pig, which is hilarious that the what I consider the current authority on the best ways to secure private key data for an individual is known online as Goat Pig.
Goat Pig. Yeah, right. I think we've pretty much covered everything. And just to wrap up with this quote from Chris Skinner, the author of Value Web and the CFO of The Financer. He says, blockchain is reinventing the infrastructure that enables us to transact globally between institutions in real time. It's not just about banking. It's going to revolutionize governments, the identity of people, and the whole way we think about how we record transactions. Something we will see for the next decade. Changing everything. It's a distributed database you can trust.
Yeah, that's going to change everything eventually. There's a lot of coding and adoption and groups of people agreeing on how it all works before that's going to happen. But here's the thing. No matter how long it takes, they're never going to uninvent Bitcoin.
That's right.
It can't be uninvented. So, it really is just a question of how long. How long will this take?
Yeah. The one thing we can say for sure is it's not going away.
Yeah. We as humans have to figure all this out and get together and do it because it's not done yet.
All right. Well, Andy, thanks so much for coming by.
Awesome. Yes, this was really fun. I enjoyed talking about this stuff.
Fun.
And I appreciate that you and your listeners tolerated me going down the rabbit hole on Bitcoin.
And thank you, everyone, for tuning in to this episode of Device Squad, the podcast for the mobile enterprise from Propelics. All right. See you next time.
Unless it has a cryptographic signature.
You turn into Arlo Guthrie.
And we turned all the signatures into a meal. And we ate the meal. And there was Bitcoin. I don't know. I don't know if I'm actually doing a good Arlo Guthrie, but I feel like I get that kind of exuberance when he gets excited, you know?